All right, let's continue on problem 56 here. So you should have filled in A through E already and checked your answers. Make sure that you have those correct now, or else we are going to make some mistakes moving forward. So part F says to graph the sequence here. So all we're going to do is plot the points that you created in your table, which are just all of the list of numbers from the question, and your N is just all of the it goes from 1 to 5 just in order. It just tells you what number in the list these numbers are. Okay, so I'm just going to plot those points. So 1, -9, 2, -5, 3, -1, 4, 3, 1, 2, 3, 5, 7. Okay, graph the sequence. Check, that's done. Should the graph be continuous or discrete? So what this really means is, should I connect the points? That's what continuous means. Connect. Discrete means do not connect, not connected. Okay. So, and why? So what we need to ask ourselves is, again, should there be any data in between numbers, the first number and the second number in our sequence or in our list of numbers? So the table we filled out, these numbers again, I mean the order that these things show up in the list. So the first number is -9, the second number is -5, the third number is -1. Is there a number in between these in the list? It's just the first number and the second number. So there's nothing in between, so there really shouldn't be a 1.5 term in my list of numbers because it skips over those other numbers in between. So since I can't add a value in between, the first or second number in my list, these should be discrete. And why? Because there's no half terms in my list. Okay. So there's nothing in between the first and second term or number in the sequence. Which again, the sequence is just the list of numbers. So since there was nothing in between -9 and 5, there's nothing existing there. Since my pattern's adding 4, I can't just say, okay, there's a number in between. To get to the next thing, I got to write away to -5. So since there's no number in between these two in my list, I can't have a point at 1.5 blah, whatever. Okay? There can't be a point at 3.5 whatever, because nothing exists in between those. So that's what it means to be discrete. Continuous means if I connected the points. So on the next page, go ahead and flip that over. It says to write the equation for the nth term of this sequence. All right, so I'm just gonna pull away some of our other stuff for a second, but let's just think here. What does this graph, what shape is it kind of looking like? All right, we saw with when you categorize the different types of sequences, all the ones that looked like lines, like this, are arithmetic, which means they're adding the same thing every time. So they look very similar to lines. I'm gonna scoot this up here. So this is an arithmetic sequence, which means it's going to be really similar to the setup for a line equation, which is y equals mx plus b. Okay. However, in this problem, it's just going to be set up a little differently with different letters involved. Okay, so instead of like a line, we're not going to use y and x. We're going to use t of n here, and we're going to use an n right here. Okay, if you notice in your table, those were the letters in your table. So this m meant slope for us normally. Now it's just going to mean the common difference times n. So just like slope, okay? It just means the change. And then our b, instead of it's being called the y-intercept, now we're going to say maybe it's the starting value. Or we can call it the 0 term. That's a little small up there. But so we're going to set it up in the same way as a line, but we're just using different words and different letters. So our problem already starts with t of n, okay? This is instead of y equals, or just different letters to show that we're working with a list of numbers instead of connecting the points. So write an equation for this. Our common difference was it was adding 4, so I'm going to write 4, kind of where my slope normally goes. And then instead of an x, I'm going to use the letter n, just to stay the same. plus the starting value, which actually in our sequence here, okay, if we go back to our paper, back to our first part, the starting number is what you actually found out right here already, okay? We had to go backwards in our list to find that out. So it's not actually the first number written on the paper, it's the one that would come before that on your list, okay? So we're always gonna have to go backwards to find the starting value. So to do that, we just took away the adding 4, we did the opposite and went backwards 4. So that's why this is negative 13, that's why this is your starting value. So in our equation, we're gonna write minus, or we can write plus negative 13. Okay, oops, write that. Or we can take away that plus sign and I can write it like this. T of n equals 4n minus 13. It's the same thing if I had that plus negative or if I just have the minus. Okay. What is the domain for the sequence equation you have written? So domain again means x. In this case, we're not using x and y, but you were using n. So what are the n's that we used? Okay, if we go back to the table, they were 1, 2, 3, 4, all those numbers. If you know what those types of numbers are called, those would be called kind of your counting numbers, or they're actually technically called natural numbers. Okay, but they start at 1 and go on from there. Okay. How is the common difference related to the graph and the equation? Why does this make sense? So the common difference was 4 again, it was adding 4. And where do you see this in the graph? All right, if I go back to my graph, I'm just going to bring that little part up again. All right, right here, we can see the change from this point to the next point as I'm going up. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So that's our slope. All right, the common difference is our slope in the graph. That's how steep the line is. Okay, so related to our graph, it is the steepness of the line, or also called the slope. Okay. And where do you see it in the equation? Well, it's next to the variable in the equation, which is also our slope. Next to the variable, which also means it's the slope. Okay. Why does this make sense? Well, they both represent the slope. They're just showing you this in a different way. One is on the graph and one is where it is in the equation. Okay. So go ahead on to the next page now, and we're going to look at the next problem.